Welcome to my discrete math lesson on apportionment. Apportionment is dividing a set number of representatives fairly among populations of different sizes. There are different methods to do this. In this lesson, we're going to learn about the Jefferson and the Webster methods of apportionment. First, the Jefferson method. In the Jefferson method, we're going to start by finding the ideal ratio. That means how many people should each representative represent. To do that, we're going to take the total population divided by the number of seats. Then we find the quota. That means we take the population of each group, divide it by the ideal ratio. Here, we truncate the quotas. Truncate means that we just drop everything after the decimal points. And that's going to be how many seats that particular group gets. We add up all the number of seats and see if that matches the number of seats we have available. If it does, great, we're done with the problem. However, often what happens is that there are extra seats available that still need to be assigned. Therefore, we'll need to find the adjusted quota, or the adjusted ratio. To find that, what we're going to do is take the population of the group and divide it by the truncated quota plus 1. Or in other words, our answer from part 3, 1 more. Then we're going to give the seat to the group that has the largest adjusted ratio, because that means that the group is still fairly being represented in a similar manner to the other groups. Let's go ahead and do an example. We're going to do an example based on Rhode Island. Rhode Island has 75 representatives in its House. And we're going to divide these representatives based on the population of each county. So below you'll see the population of Bristol, Kent, Newport, Providence, and Washington counties. This gives Rhode Island a total population of 1,052,546. The first thing we need to do is find the ideal ratio. This means how many residents does each person represent. Remember, in order to do this, we're going to take the total population divided by the number of representatives. In this case, this means 1,052,567, our total population, divided by the 75 representatives. Rhode Island's ideal ratio is 14,034.23. Again, this means that each representative represents 14,034 people from the state. Now we need to fairly divide these between the counties. In order to do this, we're going to divide the population of each county by the ideal ratio, and then we're going to figure out the quota for each county. Each population is divided by the same number. So for example, for Bristol County, 49,875 will be divided by my ideal ratio of 14,034.23. Based on this, Bristol County should get 3.55 representatives. Divide out the rest of them, verifying the work on your calculator. Again, this is just a calculator problem, but double check that you can get the same answers that I'm going to display here. So these are the quotas that you get when you divide each county by my ideal ratio. Okay, you'll notice I left these as decimals out to 2 places. Now we're talking about representatives, actual people. We can't have a fraction or a part of a person. So we're going to somehow need to convert these into whole numbers. And here is where we find the difference between the Jefferson and the Webster method. So now we're going to focus on the Jefferson method. For the Jefferson method, what we're going to do is we're going to truncate each of those answers from before. Truncate means that we're just going to drop everything after the decimal point. When I truncate, Bristol County will get 3, Kent would get 11 representatives, Newport 5, Providence would get 44, and Washington would be 9. Now when you add them all up, that gives us a total of 72 representatives. However, if you remember back to the basic premise of this problem, we said that Rhode Island had 75 representatives in its House of Representatives. Okay, we've only assigned 72 seats. We need 75. So what we need to look at is, okay, well, what would happen if I gave each of those groups one more representative? Would it still be fair? So what we're going to do is find the adjusted ratio. That means we're going to take the population of the group and divide it by our truncated quota plus 1. So we're going to take the answers from the previous slide, increase each of them by 1, and find what that adjusted ratio is. Then the group that has the largest adjusted ratio is going to get the extra seat. So again, I have the population of each county. I'm taking the values from my truncated quota. I raised each of them by 1. And now I'm going to divide my population by that new quota and see what my adjusted ratio is. Again, this should just be a calculator problem. So 49,875 divided by 4 gives us our new adjusted ratio of 12,468.75. Again, please verify that you can get these totals. I just divided the population by my truncated quota plus 1. And you might want to pause the video and make sure you can get these adjusted ratios. Now, what we need to determine is who deserves the extra representatives. And remember, we actually have 3 extra representatives because we had 72 seats, but there are 75 that we need. So we're going to start by giving them to the group with the largest adjusted ratio. So Providence still has the largest adjusted ratio, and that means that each representative represents 13,925 people. The second largest adjusted ratio is in Kent County, 13,846.5. And then the third one goes to Newport with 13,814.67. Okay, so let's summarize exactly how many representatives each county got. Bristol did not get an extra seat, so they stay with their truncated quota of 3. Kent received the extra seat, so they are up to 12. Newport also got an extra seat, so they have 6. Providence got one more seat to be 45. And Washington did not get an extra seat. They remain at their original total of 9. Add those all up, and we assigned all 75 representatives. Now let's compare this to what happens using the Webster method. The Webster method starts out very similar. We're going to find the ideal ratio, which is where we took the total population divided by the number of seats. We're going to find the quota by taking the population of each group, dividing it by our ideal ratio. Here in number 3, we're going to round the quotas. That means if it's 0.5 or greater, we're going to go up. If it's less than 0.5, we're going to go down. And that's going to be our initial number of seats. We're going to add them up and see if it gives us the number of seats we want. And if it does, then we're done. We're going to stop there. But often what happens in the Webster method is that our seats assigned are actually too many. So if the number of seats available and assigned don't match, again, we're going to find the adjusted ratio. But this time, we're only changing our quota by 0.5. And here we have to figure out if we've assigned too many seats or too few. If we have extra seats, we're going to divide by the truncated quota plus 0.5. But if we gave away too many seats, we're going to take it by the truncated quota minus 0.5. Then to figure out what to do with those seats, we're going to give the extra seat to a group with the largest adjusted ratio, just like in the Jefferson. But if we had too many seats, we're going to take a seat away from the group with the smallest ratio. Let's look again at Rhode Island. We're going to start out the same way, so I'm not going to recalculate this. Remember, we found the ideal ratio by taking the total population of Rhode Island, dividing by 75. That meant that the ideal ratio was 14,034.23. I divided each county's population by that to find the quota. Here we're going to do it a little bit differently. Now, in the Webster, we're going to round the quota. So again, that means we have to look at our answers and decide if we should raise them up or if we should round them down. So looking back in the video, before we had 3.55 as our quota for Bristol County. We're going to round that up and say Bristol gets 4 seats. Kent had 11.84, which means we're going to round, and that would also go up to 12 seats. Newport was 5.91, which would give them 6 seats. Providence was 44.65, which again rounds up to 45. And Washington was 9.05, which rounds down to 9. Add those up to see how many total representatives we've assigned. We've given a total of 76 representatives. Again, the basic premise of this problem was that there were 75 seats available. So we need to figure out what happens with the seat that we overassigned. We're going to compare and see what would happen if we reduced each group's representatives. In this case, to find the adjusted ratio, we're going to take the population and divide it by the rounded quota minus a half. And we're going to have to take that extra seat away from the group with the smallest adjusted ratio. So now I've lowered each groups by 1/2 or 0.5, and I'm going to divide out the population divided by the adjusted quota. So 49,875 divided by 3.5 gives us an adjusted ratio of 14,250. Repeat the process for the next, and again, you might want to pause the video and double check that you can get these answers. If we look at the adjusted ratios, again, we're going to take away from the group that now has the smallest ratio. So the smallest ratio is Providence. So Providence is going to lose one of those seats that we looked at earlier. So when we rounded, initially Bristol had 4 representatives. They get to keep those. Kent gets to keep the 12. Newport keeps the 6. Providence was lowered. Instead of 45, they now have 44. And Washington kept the 9. If you add those up, that gives us a total of 75 representatives. The key here is to look at what we assigned for the Webster method versus what we assigned for the Jefferson method. You'll notice here that Providence only had 44 representatives. If you look back at the Jefferson method, in the Jefferson method, you'll notice that Providence had 45 representatives, where Bristol only had 3. So often what's going to happen is that you'll have different amount of representatives between Jefferson and Webster. It's not always the case, but it's very possible that these two methods will give you different apportionment answers.